Okay, so we're going to start with example number 2. Not that you guys knew that already, but example number 2 from your notes. Okay, again, how do I know just looking at this proof that it's got to be done indirectly? What tells me right away it's got to be done indirectly? Let's try out 15. What's up?
It says that AE isn't equal to.
Correct. If I'm asked to prove something's not equal, not happening, we better be doing this indirectly. All right, so I wrote all my givens. Next step, I need to assume something is true. In this proof in particular, what am I going to assume is true? 8. We don't have, or now we do. Yes.
You have to assume that AE is equal to CD.
Good. Please remember, you assume the opposite of the proof. Don't look at the givens. AE is congruent to CD. Assumption. Good work. All right, this one's a little bit different than what we did yesterday because now you have to recognize I have 2 givens right now. I have altitudes AE and CD, and then I have ABC scalene. We need to contradict one of those. And I know yesterday it was easy. I just looked in the givens, I looked for the one that had the word not with it, and that's the one I contradicted. Well, none of them do here. But we still got to contradict one of them. So I'm going to turn this over to you guys. Out of those 2, which do you think would be the easiest to contradict? ABC scalene or AE and CD or altitudes? What do you think would be easier to say the opposite of? What would it be easier to say the opposite of here? Or prove the opposite of? Got a suggestion, Zach?
Yeah, that the triangles isosceles.
Whoa. So you're going to contradict it scalene.
Yeah.
How would you contradict it being scalene? Prove it's not scalene, which is another term. Name another triangle that's not scalene that we've talked about. Right? If you guys can show me triangle ABC is isosceles, that contradicts that it's scalene, doesn't it? Can't happen at the same time. Great job. So that's what we're going to do. Together as a group, let's try to prove triangle ABC is isosceles. And this is going to be a tough one here. All right, it's going to be a tough one. What do I need for it to be isosceles? I just want to keep brainstorming. Romeo, what do I need on this triangle to be isosceles?
2 angular sides to be.
2 sides or 2 angles, right? And usually I get that by proving triangles congruent. Okay, so I need 2 angles or 2 sides, so I need a pair of triangles congruent. Well, let's look what we have already. We have segment AE and segment CD are congruent. What do altitudes do again? Remind me, what do altitudes do again? 22. If AE and CD are altitudes, they're forming what? There we go. So everyone take a look. I got a right angle here at AE, at CD and AE. I have right angles there. And also keep in mind, CD and AE are congruent by your assumption. Does anybody see a pair of triangles I may want to try to prove congruent based on all this info? Take a look. I'm going to ask somebody in a second. If you already know AE and CD are equal, and I just threw those right angles in because they're altitudes, anybody see a pair of triangles that maybe I'd want to try to prove congruent because I do have a lot of information about them right now. And also they have an angle or a side in the big triangle because I need to get it isosceles. All right, so here we go. Let's turn it over. Any triangles up there you think might be a good idea to start with? 16?
ABE and CDB.
So you want to go, let me see. I just want to make sure I got these here. This one, right? This overlapping one? And this overlapping one, I got them, Carter? Those right there? Okay, I just want to make sure I got them because I'm okay with that. That's fine because these are right angles, aren't right next to them right angles too because they're altitudes, so that's fine. But did anybody going to say the 2 bottom overlapping ones? You could have done that too. That's fine. We'll roll with Carter's, okay? Because we can do that. All right, good job, Carter. We'll roll with that. Is everyone all right with those 2? You could have also done the bottom 2 as well. All right, we could have done the bottom 2. And actually, Carter saved you guys because proving the bottom two is a lot tougher than the top two that he picked. So, all right, let's do it. You guys have a pair of sides right here, right? A, E, and C, D. You guys have a pair of sides right there. What do I still need to put in my proof, too, that I marked on my diagram but has yet to get my proof? Lisa? Yep, make sure they're in the triangles that you need. So triangle BDC and angle BEA are right angles. I don't know why that took me so long. How do we know they were right angles, by the way? Because this is not our traditional perpendicular lines form right angles, right? That's not what I can write here. There's another reason why I knew they were right angles. 21, why are they right angles? Altitudes form right angles, or definition of an altitude would be fine with me. Good, Scott. And usually the next step, you tell me what about the right angles now? They are congruent. Good. All right, got a pair of angles now. So I had a pair of sides from the assumption. Now I have a pair of angles. All right, we need something else now from those two. We need something else. And I've used all the givens. They're out. So probably something on your own here. So go ahead, take a peek at those triangles. I'll call on somebody here in a second. What else can I get from those two triangles? Okay, see if we see anything here. What else is true about those two here? 1's 11. Anything else you see?
Sadly, we don't have an 11.
19. Do we see anything?
B.
Angle B shared both, right? We got that reflexive. Anytime triangles overlap, look for a common angular side, which is I have here. So I got angle B equal to itself. Reflexive. Good work. So that gives me my third and final pair that I needed. I just got to figure out the correct method now, right? Triangle. Let's see, how am I going to name these? AEB. All right, so if I call that AEB, I got to go CDB. All right, what's your method? What is your method? Draw it out if you have to as well. Draw it out. I got two angles and a side. I got two options, but only one's correct. I got two options with two angles and a side, but only one of them is going to be correct in this one. Oh, 1, 4. Got a method? I don't have a feeling. Do we have a 14? No, I had a feeling. Where were you on that, Via? You're slacking.
What?
Yep, exactly. George, hello?
Angle, side.
Darn right. Kid was ready. He knew it too because I said studs only. Angle, side. Debatable. Remember what our goal was? Get it isosceles, right? Well, you guys said I could get two angles. I think it was Romeo said I could get two angles or two sides. I can only do one here. So after the triangles are congruent, what am I going to have to say by CPCTC? The sides or the angles? I got to do sides. I can't say this angle's congruent to this one by CPCTC. That's not even in the darn triangles. So I need to say AB congruent to BC. CPCTC. Now what type of triangle do I have? So in step 8, you're going to tell me triangle ABC is it's isosceles.
No, it's not. It's supposed to be a same unit. So the assumption was a liar.
Just going to let it sit. Try to ignore it. Why is this triangle isosceles? I have Emma.
Assumption led to a contradiction.
Ooh, no. That's not why it's isosceles. We're not even done with the proof yet. I'm just saying triangle ABC is isosceles. Assumption led to contradiction is going to be why the proof statement's correct. I need to know why this is isosceles. Triangle ABC is isosceles. Molly, what did we just do? Two congruent sides, which was AB and BC, means I have an isosceles triangle. Now, didn't I just contradict with the given? Did I just contradict the given? What did the given say? It was scalene. What did you just say? Isosceles. And what led us to it being isosceles? Our assumption, which is false now. So if that's false, we write the opposite's true. So AE not equal to CD. This will be my assumption led to a contradiction. And don't forget. Prove to me you know what a contradiction is. What lines here? What lines are my contradiction in? 16, what lines?
1 and 8.
Given, always. As long as you put the givens first. If you put it second, you got to put a 2 there. And triangle ABC is isosceles. Scalene isosceles contradict. Any questions? All right, it's game time for you guys. The only thing I would like you to cross out is number 5. Don't do number 5 because we just did it. For some reason, I copied both of them in there. So you guys have 1, 3, and 4. Play your cards right. Easily done before the end of the period. At least one person in your group or more. Chromebooks out. Open with the answer key. Let's go. Please just don't copy the answer key. Please don't do that. Check your work after you're done. Let's go. More than one can have the. I want answer keys, so after you do a proof, you're checking it.